everyone, and welcome to the last part of Lesson 5.4. So this problem is going to be looking at volume, and specifically taking a volume of water or liquid and transporting it out of a tank, basically like emptying a tank, and they want to know the amount of work that would be. So what I've done is I've boiled it down to 5 basic steps. I didn't always say basic, but yeah, these 5 steps will get you through the question. So the first step is to find the volume of one slice, and we should be kind of familiar with this. What we're going to do is we're going to take the shape of whatever the tank is. It might be a rectangular prism, it might be a cone, it might be a cylinder. So you're going to take this shape and we're going to divide it up into infinitely narrow, infinitely skinny little bits like this. We're going to find the volume of this one little bit, and then we're going to add up all of these volumes together. Okay, so we need the volume of one slice of this object. Okay, then we need to find the mass of that slice. Okay, so that then we can find the force on it. Okay, so find the volume of one slice. So basically that's going to be like almost the area of one of these slices. The mass of it is volume times the density of it. So how much material it has in it, the density of that material. Okay, then you find the force on it, and that's mass times gravity. So you're going to take, we take the volume times density times gravity, and that's going to be the force. But remember, work is force times distance. Okay, so we found the force now. Now we have to multiply by the distance. So we need to find the distance traveled by the substance. If I'm pumping it out the top, that's going to be different than if I'm pumping it out the bottom. Okay, so distance traveled by the substance. And then we're going to use our general integral. The integral from the lowest point to the highest point of our substance of force times distance dx. Now, a lot of times we're talking about a vertical distance, so a lot of times instead of using dx, I'm going to use dy, and I'm going to use y as my variable, because a lot of times that distance is going to be a vertical distance. So let's take a look at an example and see if I can make this a little more clear. Okay, so there are my steps. I'm going to try and keep them up here along with the question that we're being asked. Okay, so example 5 says a tank has the shape of an inverted circular cone. And you've noticed I've tried to sketch as best as my limited drawing abilities can our circular cone. It has a height of 10 meters and a base radius of 4 meters. It is filled with water to a height of 8 meters. Find the work required to empty the tank by pumping all of the water to the top of the tank. So first, let's do step 1. Step 1 is the volume of one slice. Now notice these are circles, okay? So that means I have pi times radius squared times the change in my measurement, okay? And I like to call that dy, or delta y in this case. But notice, I need this radius in terms of y. Now, you don't always need to do this extra step. Sometimes you will, sometimes you won't. What I'm going to do is I'm going to use similar triangles. Okay, and I'm going to just try and simplify this out. This is our big general outline of our tank. It's 10 units tall, and the radius is 4 units wide. Oops, let me draw that on the other side. So here is 4 units wide here. Now, anywhere in this, I'm going to have a similar triangle like this. That's going to be y units tall and r units wide, and that's going to be the radius at this given point. So I'm going to create a proportion. 4 over 10 equals r over y. And now I just need to solve this for r so I can get this in terms of y. So I'm just going to multiply by y on both sides. So I have y times 4 over 10. And that can reduce. So the simplified version of this is 2/5 y. So in step 1, I'm just going to take this and put it in for my r squared. Okay, and I will get pi times 2/5 y squared delta y. Now, later on, when I put this into my integral, this delta y is going to turn into a dy. And I'm just keeping it this way for now because that doesn't happen until we put it in our integral. Although a lot of times when I'm doing my work, I just leave it as a dy. This is the technical way it should be. Okay, so that's step 1. Step 2, I need the mass of one slice. And that's the volume, which I just got, times the density. And it said the density is 1,000. Okay, so what I'm going to do is I'm going to do 1,000 times, now this I'm going to simplify a little bit. This is pi times, if I square this, I get 4 over 25 y squared delta y. And again, this can be simplified more. 1,000 times 4 is 4,000. Let me get my calculator. And 4,000 divided by 25 is 160. So this is 160 pi y squared delta y. Okay, looks like I need to move up. So moving up. Number 3, it says find the force on one slice. So this is mass times gravity. And again, I'm working in meters and kilograms. If we were working with weight, like pounds, I would be able to skip this step. I can't skip it because we're working in meters and kilograms. So step 3, I have to take this and multiply by the gravity constant, 9.8. So 9.8 times 160 pi y squared delta y. Okay, and just simplifying that, 9.8 times 160 is 1568 pi y squared delta y. Okay, now the distance. This takes a little thought. Okay, for distance, okay, the substance, remember, is getting pumped up to the top. Okay, so if I have this at a height of y, then the distance it needs to travel is this distance here. It's going to be the total 10 minus that y. So like if y is 2, it has to travel 10 minus 2, or 8 units up before it can get pumped out. Okay, if y is 4, then it would travel a distance of 10 minus 4 to get to the top. Okay, so my distance is 10 minus y. Okay, now the last thing I need to do is put this in my integral. Step 5, I have the integral of 10 minus y, my distance, times my force here, okay, and the delta y turns into a dy. Now, the last thing I need to do is put in my upper and lower bounds on my limit. And remember, at the very beginning, they told us we have a bottom at 0 and a top of my water level at 8. So it's going to be from 0 to 8. Okay? So this is 0 to 8. Now, I just need to finish this integral. So let's take a look. Okay? So I'm going to take this constant and pull it out. Okay? And then I'm going to do y squared multiplied into this. I have 10. Oops, I forgot my integral there. Okay, y squared times 10 is 10y squared. Y squared times y is y cubed, and it's dy. Now I'll do my antiderivative. This is 10 thirds y cubed minus 1/4 y to the 4th, evaluated from 0 to 8. And later on, we're going to multiply by 1568 pi. Now, with my calculator, I know that 8 to the 3rd power is 512. times 10 is 5120 over 3 minus 8 to the 4th divided by 4 comes out to be 1024. And if I put in 0, I'm going to get 0. So I just have to calculate this with 1568 pi at the end here. So getting common denominators, I would do 1024 times 3, which is 3072 over 3. And 5120 minus 3072 is 2048 over 3. And then this whole thing needs to be multiplied by 1568 pi. So times 1568 gets me 3211264 over 3 pi. Okay, and according to my calculator, that comes out to approximately 3362827.8 joules. Okay, that's it for this lesson. Let me know if you have any questions.